Now here's an even more complex example. Calculate the range of a javelin that is thrown by an athlete at an angle of 20 degrees with a velocity of 18 metres per second if the point of the javelin was 1.8 metres from the ground when it was launched. Now it says 20 degrees, it doesn't say from horizontal or vertical. Assume horizontal unless it says otherwise. So what we've got here is javelin is launched. That wasn't a very good parabola, never mind. Comes down to the ground here. This distance here is 1.8 metres. This angle from horizontal is 20 degrees and the initial velocity was 18 metres per second. Okay, I'm going to need to know this velocity in horizontal and vertical. So that is, if I draw a slightly larger version of the diagram, that's 18 metres per second. Again, I'm exaggerating the angle. This component, this is 20 degrees. This component is 18 sine 20. And this component is 18 cos 20. Okay. We have to work out the range, which means we're looking for that whole distance. That's the range. Okay. Two problems linked by time. So, initial vertical velocity, 18 sine 20, which is 18 sine 20, 6.156 metres per second. Horizontal is 18 cos 20, 16.914. 18 cos 20, 16.914 metres per second. Much more horizontal than vertical, which is correct. Acceleration vertically is minus 9.8 due to gravity, and horizontal is 0, so this will be the same, that doesn't matter. The times are linked, they are the same, and I want to know the range, which is the horizontal displacement. What I do know is when it gets there, its vertical displacement will be negative 1.8. Okay, it's negative because it's going to be displaced downwards to get to here. Okay, now I can solve this. To solve this part I need the time, and I can get the time from the vertical. So how do I get the time here? U, A, S and T. S equals ut plus half a t squared. Minus 1.8 is 6.156 t minus 4.9 t squared. That's a quadratic. I like a positive a, 4.9 t squared minus 6.156 minus 1.8. I'm not going to try and do that in my head. I'm going to use my graphics calculator. Polynomial, degree 2, 4.9, negative 6.156, and negative 1.8. Solve. Okay, t equals 1.5 seconds or negative 0.24 seconds. Now this solution, you see, would have been over here. It's as if it was launched from the ground 0.24 seconds earlier. That solution won't help us. We want this solution. Okay? So, must be positive. Therefore, t is 1.5 seconds. That's the same on this side. Having got that, I can solve this. There's no acceleration, so all I'm using is speed is distance over time. I'm solving for the displacement, ut. That's 16.914 times 1.5. Okay, menu 1 times 16.914. I had that number there, could have been easier. 40.37, near a centimetre will do fine. 7 metres. Range is 40.37 metres.